Here we have a diagram of a cuboid. The length AE is 6 centimeters. The length EF is 12 centimeters and FG is 5 centimeters. We want to find the length of the side EC. EC goes right across the box from this corner to this corner. The idea is that we find a right-angled triangle that contains the side we want, and we can do that as shown. This would be right-angled here at G. Let's draw this triangle out. So we're drawing out the triangle EGC. We know it's right-angled at G. Here we have E, C, and G. We're trying to find the length EC, so let's call that X. We know the length CG is 6 centimeters. But we don't know EG, so let's call that Y. Clearly we don't have enough information yet in order to find X. We're first going to need to find Y. We start by finding a triangle that contains the side EG. This triangle here would do the trick. We can see that this triangle would be right-angled at F. What we need to do is draw this triangle out. So we're drawing the triangle EFG. We know it's right-angled here at F. So we have E, F, and G. EG we've called Y. From the cuboid we can see that EF is 12 centimeters long and FG is 5. We can now use Pythagoras' theorem, which is a squared equals b squared plus c squared. Remember, A is the longest length. If we call this A, this could be B, and this C. Substituting in, y squared is equal to 12 squared plus 5 squared. Calculating this gives us that y squared is 169. Note we don't need to proceed to find the value of y. Now looking at this triangle, the longest length is the A, and call this B and this C. Substituting into Pythagoras' theorem, x squared is going to be y squared plus 6 squared. But of course we know y squared is 169. So x squared is 169 plus 6 squared. So x squared is 205. X then is the square root of 205. So x is 14.317 and so on, which is 14.3 centimeters, correct to 3 significant figures.